We'll get started. Welcome to Dev 207, What's New in C# 4 and Visual Basic 2010. My name's Ivan Tolson. I work for Mindscape, we're a small software tools vendor in Wellington. This is a 200 level session. That officially means I'm not going to be showing you any code. So how they expect me to demonstrate two programming languages without showing you any code? I'm not sure, so I won't tell if you won't. So the agenda is pretty much what it says on the tin. We're going to look at some Visual Basic stuff, and we're going to look at what's in C#. There is some stuff that overlaps between the two languages, so we'll be covering that off. So just to get me a bit of a picture of what the audience is, how many people here use Visual Basic on a regular basis? It's a pretty good number. How many people use C# on a regular basis? Even bigger number. Okay. So we'll be talking about Visual Basic first, probably the lesser part of the presentation, but there's also, as I say, there's some common stuff between the two languages, so hopefully that will still be interesting to the VB guys as we get towards the end. So I think the best thing to do is just plunge straight into some demos, take a look at what's actually new in VB 2010, and I thought we'd start by looking at an old school Visual Basic class. So this is the sort of thing that you're probably familiar with having written in VS 2008. And there's a few things here that they're pretty routine, but they may be a little bit annoying to you. For example, you've got, say, a number of parameters here. We've got to use this little line continuation character all the time, which kind of clutters up our code. So wouldn't it be great if we could get rid of that and not have to worry about that? Would that be great? Yeah, that would be great. Thank you. So, tough audience. Okay, so let's just try getting rid of it. Let's just try deleting it out of everywhere that we see it. Ooh, lots of IntelliSense. And let's see if that builds. Hey, someone's impressed. There we go. 0 errors, 0 warnings. We don't need all those little warts anymore. In fact, let's try getting rid of even more of them. How about that? Look at all those. Let's get rid of them all. Oh. That's not looking so good all of a sudden. So, unfortunately, although we can get rid of those little line continuation characters in a lot of places, there are places where we'll still need them. Basically, if Visual Basic can figure out when it sees the end of a line, hang on, that can't be a complete expression, then it will carry on looking on the next line. So, for example, we can get away with omitting the line continuation character after the from, because a from on its own doesn't make any sense. VB will know to go look at the next line. But at the end of this where, that could be a complete where clause. So we do need to give VB a little bit of help and say, no, we do still need you to keep looking on the next line. There's another rather verbose piece of code sitting around here. So this is a pretty routine property. There's nothing exciting going on there. Now, sometimes exciting things do happen in properties, particularly in my code. But this one, all of that, creating a backing field, creating a get to return the backing field, creating a set to set the backing field, it's not really adding any value. Wouldn't it be great if we could just say, look, I just want a nice, simple property with no special fancy stuff going on? Kind of like that. Do you think that builds? I think that builds. Now you may go, well, that looks awfully like we're just dimming a field, a private field, and we know that's a bad idea. This is actually generating a real property and a backing field for it and those getters and setters. You're not able to put any business logic in there, so it is pretty dumb, and it's not actually doing a lot more at this stage than having a public field. But what it means is that if you later need to add something to that code, if you need to, say, add some validation to the setter, for example, then you've got a property in place. And that means that any clients that are already expecting that property to exist, anything that's been compiled against that property, will keep on working, even though you change the implementation to being an explicit property setter rather than a sort of implicit automatic one. Whereas if you change from a field to a property, all your clients would have to recompile. Does that all make sense so far? Okay. Now, here I'm having to set up an array, and again, this feels a little bit on the verbose side, because we're having to anticipate how many things are going to be in the array, and then we have to iterate through actually setting up the elements of the array. It'd be nice if we had some way of just being able to initialize that array directly as a literal. So, VB10 has added the facility to do, let's just get some typing going on here. So I can put those squirrely brackets around, I can put braces around a list of strings or whatever the type of the array is, and that's what they call an array literal. So that is actually going to be, that is doing the same as the previous thing. It's actually creating an array of length 2 with the appropriate elements, and it's assigning that back into the edibles variable. And obviously the code there is much more concise than what we had before. Again, everything is still happy there. But arrays are pretty old school. Nowadays we've got generic collections, we've got list of T. What about that? Can we initialize that? And the answer is yes, we can, but the syntax is a little bit different. So here I've got a list of integer, and I'm initializing it from this set of integers. So it's like saying 1, 2, 3 is my array literal, and I want to initialize my list from that array. So we need that extra from keyword. Now, that's nice and simple for integers, but often you're going to have lists of more complicated things, like classes. So obviously, you can use the same syntax there. So here we're going to do a dim class is a list of my old school class. And now we need to create one. We need to put something into that literal. And this is, again, feels a little bit verbose. It's the traditional syntax. You're newing something up. We're using a with clause to assign a property. And that instance is then going to get put into that list. But it'd be nice if we could do something a little bit more concise than that. So if we look down here, it would be nice to be able to write something where we were just passing in the information that was interesting. We already know that that list is going to be of my old school class from the declaration. It's tedious having to write the new all the time. So Visual Basic also allows you, if you create an extension method, that will get called implicitly. So the way that that list from syntax works is basically it compiles down to a set of add calls for the things inside the braces. If you have an extension method on the list type called add with arguments that you want to pass to your initializer, then VB will call your extension method when it does the add. So if we look here, we're doing a from, and we're just passing essentially these tuples, these just pairs or triples or whatever, of values. So Visual Basic is going, well, Visual Basic will look at that and go, that's not the appropriate type to go into this collection. That's not a my old school class. So it will look for an extension method with the appropriate things. In this case, it needs 2 strings that it can feed to the extension method. So now we have an extension method down here. It takes 2 strings in addition to the class, and all it does is it news something up with the appropriate properties and adds it. So if we round run that, then we can do a classes2 dot for each. So C. And if I, let me just pin this window here. If I now run that, you can see it has actually created classes there, and it's assigned the appropriate members, and I'm able to write them out. Now, something else that you'll notice here is that I've been able to use a lambda expression. Now, we've had lambda expressions since Visual Basic 9, but in VB9, only functions could be lambdas. So a lambda expression was something that returned something. If you wanted to pass a subroutine to something like list.forEach, then you actually had to write a method and pass it via address of. So you had to sort of spin out all these little tiny methods just to do a console.writeLine. In VB10, you've got what they call statement lambdas, which are the same. You do it in exactly the same way as a function lambda. You just introduce them with sub rather than function, and they don't return a value. And that means you can pass them to things like for each, which aren't actually expecting a value to come back. Another improvement in lambdas in VB10 is that we can also have multi-line lambdas. So here I've got a link where clause, but my where criterion is a little bit more complicated than I want to put into. I don't want to have to squeeze that into one line of code somehow. It'd be a little bit unnatural. So in VB10, again, in VB9, I would have had to write a method for that and pass it via address of to the where function. Now I can actually use function, end function, and have multiple lines in there. I can even line my code up. And you can see I can actually put a whole function in there just as if it was normal Visual Basic. This works in exactly the same way as VB9 lambdas, as VB9 anonymous methods. It just allows you to put multiple lines in there to structure your code a little bit more cleanly if you've got some complexity, if you've got a little bit of complexity. If you've got a lot of complexity, you may still want to pull it out to its own method or its own class. But for something that's reasonably short, these multi-line lambdas are pretty handy. So if we run that, it will produce pretty much what you'd expect. It's gone through assigning that Boolean variable, checking that, and that's being fed into the where clause, and we've only got one thing that's passing. Is that all? Does that all make sense to people? Are those lambda expressions pretty clear what's going on there? It's pretty simple stuff. Are you happy with that? I'm hearing no protest. If people have got questions or if there's something that's not clear, sing out, yell out, let me know, and we can go into more detail, or we can cover a case that you want to see explored. Just say the word. Okay, so what have we looked at? We've looked at implicit line continuation, getting rid of all of those little end line warts from our code, or line continuation warts from our code. We looked at automatic properties, which allows us to write properties much more concisely. We've looked at array literals, so we can actually embed arrays in our code rather than having to write lots of array setters. We looked at collection initializers, which allows us to do pretty much the same thing with lists and collections and sets and so on. We've looked at statement lambdas, which are like lambdas but don't have to return a value. We've looked at multi-line lambdas, which they're lambdas, but they're on multiple lines. So that's all I'm going to talk about in terms of Visual Basic language. We are going to look at a couple more features which are shared between Visual Basic and C#, but I'm going to talk about them in C# terms. I'll mention the Visual Basic equivalents when there's any difference there. So one of those shared features is what they call generic variance, or generic covariance and contravariance. And although this is the officially correct name, it's a name that I really hate because I think it's really frightening. Whenever I see the word covariant, I think you've got to have a really bushy beard to understand this feature. When I see the word contravariant, it's actually even worse. You're going to need a bow tie as well. They sound really hardcore. Thankfully, they're not. Contravariance and covariance and contravariance are actually they're a scary name for what's actually a really simple concept. And that concept is simply generics working the way you expect them to. So what do I mean by that? What's the problem with generics that we're trying to solve? Well, let's have a look back in good old VS 2008. Let's look at C#3. And I've got a business domain which I know a lot of people are working in. I'm dealing with animals, I'm dealing with dromedaries, I'm dealing with penguins. And I know a lot of you have got the same problem as I have with this. So in C#1, Visual Basic.NET 1, we're able to deal with arrays of this stuff. So if I took, say, an array of animals, and I had a method that took an array of animals, everything was lovely. I could pass that in, and it would behave itself. So I was able to write out each of those animals, and I was able to assign something into that animal array. Now, C#1, or C# on arrays, supports variance. So if I've got an array of penguins, I can pass that into a function that's expecting an array of animals, because if it can deal with animals, it can surely deal with penguins, right? That makes sense, yeah? That makes sense? So we'll give that a go. And there we go. It deals with, oh, that doesn't look so good. What happened there? Why is it not happy? We've got this array type mismatch exception. So as long as it was reading from this collection of penguins, it was happy. Then it got to this line, where it tried to assign something back. And it was assigning that dromedary as a valid animal. And by the function signature, we were told we were going to get an array of animals. So I can surely put an animal into that. Problem is that actually, we passed an array of penguins. And when you put a dromedary into an array of penguins, things go badly because it's completely the wrong habitat. You know, they're Antarctic or something like that, I don't know. On the other hand, when they introduced generics, they decided to make this a lot safer. So if we now take that as being a IEnumerable of penguin, and I ask it to print that, well, you see, it's not happy about that. And the reason is that that print method takes an IEnumerable of animal. An IEnumerable of penguin is not an IEnumerable of animal. Basically for the reasons we've described, it's not type safe to do things with, it's not always type safe to operate on something that's actually penguins when as if it were a set of animals. The problem is this is wildly over-aggressive. The print method, all it's doing is iterating over those animals and getting their names. And because penguins are animals, because that can consume an arbitrary animal, it can therefore surely consume a penguin. It can surely cope with something that's only got penguins in it. But C#3 errs too far on the side of safety. It won't let you do that. So, what does C#4 do? Well, C#4 makes it work the way you'd expect. So let's get rid of some of these little bits, and let's bring up that same code in C#4. So we'll get rid of that. We'll have an IEnumerable of penguin, and we're going to print that. Now, the rest of the code is the same, so that's still taking an IEnumerable of animals. But this time, it's actually letting us do it. It's figured out that we're safe to pass an IEnumerable of penguin to something that's expecting an IEnumerable of animal. And that's just common sense, right? Yeah? So we're able to vary that type parameter. This is where the generic variance comes in. We're able to vary the generic type parameter by passing something that is x of derived, even though the function expects x of base. Does that make sense? Okay. So another example of that is, let's take another generic case. So I'm going to sort my IEnumerable of penguins with a penguin comparer. So that all makes sense. Passing an iComparer of penguin, that's what we'd expect. So the sort method takes an iComparer of penguin. Now, we've just decided that we can actually use derived types instead of, we can actually pass things of more derived types. So what if I pass an emperor penguin converter? Well, hang on, but that emperor penguin converter, that's an iComparer for something that's derived from penguin. That should work. We've just said we can pass derived types. We can pass derived types as generic type parameters. Well, again, let's think about what that method needs to do. That method is expecting to be able to use that comparer to compare arbitrary penguins. We're giving it something that can only compare emperor penguins. So as soon as I give it a king penguin or Adderley penguin or a yellow-eyed penguin, it's going to fall over. It doesn't know what to do with those kinds of penguin. On the other hand, if I give it an animal converter, that should work because an animal comparer, because an animal comparer can compare any kind of animal. And if it can compare any kind of animal, it can certainly compare penguins. So we seem to have two rules going on. In one case, in the enumerable case, we were able to pass a IEnumerable of derived where an IEnumerable of base was expected. In comparer, we can pass a comparer of base where comparer of derived was expected. So these things are going in different directions, completely different directions. What's the difference between them? What's the rule for when it's base or derived? The rule is when it's used as an output or an input. So let's see what the thought process of this method is. If it's taking an IEnumerable of animal only outputs animals. The animal type, the generic type parameter, only appears in the output position of the IEnumerable signature. On the other hand, in iComparer, the generic type parameter only appears in an input position. So it's an input to the compare method. And that's where the rule comes in. So if it appears only as an output, then it's safe to pass something with a generic parameter of the derived type. If it appears as an input, it's safe to pass something with a generic parameter of the base type. And that's where these terms co and contravariance come from, that you're allowed to vary the generic parameter in covariant case. I'll bring up in the covariant case, as the mathematicians call it, it's varying in the same direction as what you'd normally expect from being able to pass derived objects for base types. In the case of contravariance, the variance is in the other direction. It's allowing you to pass base objects or base types where derived types are expected. Fortunately, you as C# and Visual Basic programmers don't need to know this stuff. All you need to know is these out and in keywords. So when you declare an interface, or when you use an interface that's declared as out of T or in of T, the compiler will check. If you declare that interface, the compiler will check for you that you're not using T in the wrong way. It'll prevent you from, if you declare your interface as my interface out T, then it will stop you using T in input position, and vice versa. Similarly, you can look at the signatures of things like IEnumerable and iComparer and see what kind of variance is allowed. This, by the way, is only implemented on interfaces and delegates, and it's only implemented on a certain subset of framework interfaces. So, for example, on IEnumerable and iComparer, those have been adjusted, they've been updated in .NET 4 to have these annotations and to allow variance. If you've got an interface that's not got this annotation on it, then it will not allow variance, even though you may get lucky and it may only appear in an output position or may only appear in an input position. You've got to have these little annotations on it to allow variance. Notice also that things like list are still not variant in either direction. They're not covariant or contravariant, because in list, or iList, the generic type parameter appears in both input and output positions. So there's no safe way to vary the generic parameter, because we don't know whether that method that we're passing it to might get stuff or it might set stuff. We can only have the exact generic type. Does that all make sense to people? Is that all pretty clear how that fits together? Okay, excellent. It's pretty much, like I say, it's doing what you expect rather than being annoying to you. So hopefully not too hard to take on board. C#'s also been busy catching up with Visual Basic. The VB guys will know that VB has had optional named parameter support since version 1. In fact, since before version 1, since the VB.com days. C# is finally catching up with that, and you can now use the optional name parameters in C#. So let's take a look at that. So let's have a... So when I write that, I'm saying that the second and third parameters are optional. The caller does not need to supply those parameters. And if the caller does not supply those parameters, then they'll be filled in with the values 1, 2, 3, and 4, 5, 6. So, for example, here, I can write do stuff 888, and that will compile. And the upshot of that will be that those results get filled in with the default values. So if we just have a bit of implementation there, we'll get rid of all of this stuff. And so if we now run that, you can see the first parameters have been passed, but the second ones have been filled in. If I pass in one of those parameters, again, pretty much what you'd expect. Now, what's it doing here? It's not creating an overload, and this is important to understand. You're not actually overloading the doStuff function. There is only one doStuff function. It has 3 arguments, but they're decorated with an attribute that says these are optional and have this default value. It's also imposed some constraints, by the way, on what those default values can be. They've got to be packable into an attribute. And this has implications for versioning and interop. So if you're if a client compiles against this version of the function, so you've got another assembly that's using this version of the function, then when it compiles, if the argument is missing, the compiler will go and look at this declaration, figure out the missing value is 1, 2, 3, and store that value in the calling assembly. And that means that if you then change this to have a different default, but your client does not recompile, they'll be passing the old default value. So versioning is an issue there. The other one is compatibility. So if this were an overload, then C#3 programs could optionally pass these parameters whether they wanted to or whether they didn't want to. Because we're using optional parameters here, C#3 doesn't understand optional parameters. It will just see the one method with 3 parameters, and the C#3 program will have to pass all 3 parameters. So if you're having to interoperate with external client libraries, then that can be a significant concern for this. My recommendation is don't use optional parameters, or don't use optional parameters in external publicly visible methods. They're useful for internal stuff, and they're useful for the fact you can now interoperate. You can now call functions that have got these things. Another issue you might notice is, well, what happens if I want to override the third parameter here, but not the second? Do I have to now pass in 1, 2, 3? Well, no, because with named parameters, I can say I want to pass 999 as the argument called third, and that's now going to be passed passed into the right position. The compiler will figure out the right position and pass it in. So you can see that 999 has overridden the 456 rather than the 1, 2, 3. So this is, again, something you kind of don't want to rely on when you're designing your own APIs. So if you've got a method that takes 7 booleans, then don't rely on the fact that the caller can use named parameters to make sense of it, to make their code readable. Create something that helps them, like a little settings class or whatever. But if you are confronted with a method that takes 7 booleans, then this can be a really helpful way of making your code self-documenting. Because otherwise your maintenance program's got to figure out exactly what was going on at what time. And we'll see an application of that a little bit later on. Another thing that's been changing in the world around us since C#3 is we're now dealing with a lot more languages and a lot more environments. So as part of .NET 4, they've shipped the dynamic language runtime, which provides a sort of a common layer for talking to dynamic languages like Python and Ruby. It also can talk to, if you're in the Silverlight environment, it can talk to DOM objects via the JavaScript bridge. And it can also talk to COM objects via the iDispatch interface. So it can talk to weak-typed COM APIs. The idea of the dynamic language runtime is when you don't have type information. So in classic .NET, you always expect to have a type which tells you what are the properties, what are the methods. Everything is verifiable at compile time. In the dynamic world, that's no longer the case. The Ruby script may be supplied as an external file. It's going to get interpreted at runtime. We don't know at compile time what's in there. So to help with this, C# provides the dynamic keyword, which is kind of like the object keyword, except you can do stuff with it. So if I write object O equals make something, there's really nothing I can do with that. I don't know. The compiler will not let me do anything. Now, if I go and look at the make something method, it's kind of weird. It could return a penguin or culture info. And again, I know this is obviously a common issue for many of you. But at least I know something now that the compiler doesn't. I know that no matter what comes back from that method, it's going to have a name. So I can write o.name. But the compiler won't let me. The compiler is saying, I can't prove to myself that whatever comes back from it is going to have a name. So I'm not going to let you. And I can shriek and scream at the compiler, I know it's got a name. I've looked at the code. It's going to have a name, man. No, sorry, can't prove it. Not going to let you. So C#4 introduces a new keyword, dynamic, which basically tells the compiler, look, you don't know Jack. I'm the programmer here. I know it's got a name. You leave me alone. You get out of here. This does two things. Firstly, it gets rid of IntelliSense, which is always a good thing. Because, of course, we've said we don't know what methods might exist on this. We're trying to bypass verification. The compiler says, fine, you don't want me? I'm out of here. Screw you guys. I'm out of here. The other thing it does is it will now have to emit code to resolve that name property at runtime. It cannot be resolved at compile time because we do not have the type information to verify it. So instead, it will do essentially the same steps that it would have done at compile time. It will now do at runtime instead. So when I run that, in this case, it's going to end up returning a culture info. And, oh no, it's not going to return a penguin. I wasn't expecting that. Never mind, that's all good. And that name property has been looked up. And because the penguin is a .NET object, the runtime binder is going to use its .NET, it's going to use reflection, effectively. Now, you could say, well, okay, you looked at the code, you could have done a switch statement, you could have tested whether it was a penguin or a culture and cast it accordingly and so on and so forth. And fair enough, I could have done it, it would have been ugly, but it would have worked. Let's look at something rather nastier. So now I'm going to make something using dynamic language runtime. I've got a little piece of Ruby code that defines a penguin class and instantiates it and returns that instance. So that class does not exist at compile time. That class is actually going to get built at runtime. Now, in reality, of course, you wouldn't bake this in. It would be something in an external script file, but nevertheless. So again, I can inspect that, and I can go, well, I know that's got a name method. The compiler doesn't know that. Okay. Could I have got around that in a certain way by, say, casting to an interface or casting to a class? Well, no. In this case, I've got no escape route other than using the dynamic keyword. There is no class name, no interface name, no nothing that I could put into the code in place of dynamic. No switches, no cast, nothing that would actually allow me to access that name method, because the compiler will have no way of verifying it, even no matter what assertions I take. I can't even retrofit an interface onto that thing. So if you're dealing with dynamic stuff, something that comes from dynamic languages, then this is pretty much your only escape hatch. And we'll see another application for it in just a moment. So the main theme, I think, though, we've talked about a couple of little tactical features of C#4. The main theme, I think, of C#4 is hugely improved COM interop. And traditionally doing COM work in C# has been a little bit unpleasant. So first one I want to mention is an enhancement called NoPeer. Peer is primary interop assembly, essentially the interop DLLs between the .NET and COM worlds. And if you've seen the Office primary interop assemblies, they're pretty humongous. NoPeer works in both C# and Visual Basic. It's actually a runtime level feature. And the idea of this is that it merges those COM interop type definitions into your assembly so that you don't need to ship those interop assemblies. So what I'll do is, let's just grab a copy of Reflector, bring that up. And in fact, we've already got this built. So if we have a look at this reference to, say, the Excel interop assembly, I don't know if you can see down there, there's this little additional option there called embed interop types. And if I set that to true, which is what it now defaults to, and then go look at the assembly that's generated, you can see I've got no reference in there. Even though I've got a reference in my references folder to Excel and Word, It's not reappearing there. What I have got is bits of those namespaces copied in to my assembly. And it's been smart, it's only copied the bits it actually needs, so my assembly's not become bloated with the whole PIA, but it means that I don't need to ship the peers, I don't ship those like 20 megabytes of stuff in my application, I can just ship my assembly. There is a little bit of extra runtime magic that goes on here, and again, it's part of the runtime. If you imagine that I've built an assembly A, which uses the word paragraph type, and you've built an assembly B, which also uses the word paragraph type, and they've become embedded. Now, usually, a type, even though they've got the same namespace and name, type from assembly A and a type from assembly B are not the same type. So if I need to call your method in assembly B with one of my paragraphs, that wouldn't work. But the runtime does some magic to say, well, these are both COM types, they've both got the same GUID, so even though they're from different assemblies, I'm going to identify those two types. I'm going to let you pass an A.paragraph into something that expects a B.paragraph, and then everybody will be happy. So that pretty much solves the COM interop issue, except for one small problem. I think you know what the problem is. The problem is that COM APIs, or some COM APIs, are just extremely painful to use. We've got these very complicated parameter lists with lots and lots of options, and most of them you just never need. You formally have to pass something for them, but it's always just ref missing. You've got index properties, which C# doesn't support. You've got weakly typed APIs that return IDs perspective, they return object or some other useless type. You end up having to cast or otherwise muck around in order to actually do anything useful with these things. So COM programming in C# can be pretty laborious. Visual Basic has always been much, much better at COM programming. So this is kind of catch-up stuff. So how has C#4 addressed this? Well, we've already seen that C#4 allows you to omit optional parameters when you're calling a method. So if a COM method has got optional parameters, you can leave them out. Consequently, because you might need to call something with, say, the 1st, 4th, and 18th arguments, you want to be able to identify things by name. Again, named arguments will sort that out for you. But C# is a little bit smarter than that still. And if it sees an optional argument of type ref object, it will actually fill in the default value of ref missing. So you don't need to worry about things that have to be ref missing rather than null. You can just let C# take care of that for you. In terms of index properties, C# can now consume index properties. So if you've got a COM API that uses them, it can consume that API in a nice, even way. However, you still can't define index properties in C#. You can only use them. And those ref missing and index properties things, those are COM specials. They won't work with normal .NET classes. Named and optional arguments will work with other .NET classes. That leaves the weak typing problem, and that's where dynamic begins to come into its own. The runtime binder, the thing that sits behind dynamic and looks up those names at runtime, that doesn't just work with .NET, it doesn't just work with the DLR, it doesn't just work with JavaScript, it also works with COM. It works with iDispatch, and therefore it can handle that weak typing and send things to the appropriate methods. So let's have a look at COM programming in C#3. And these samples don't work because I lost the will to live. I honestly did. So here we go. This is a really simple piece of COM programming. Instantiate Word, make it visible. We're going to add a new document to Word, and we're going to pass some tasty ref missings. We're going to get the range, we're going to do an insert after. I can't even pass the file name to save as a literal because save as is declared as being ref. I've actually got to create a variable of type object, not of type string. Initialize that and pass that in. And then I've got to pass ref missing, come on, sing with me here, ref missing, this goes on. I can do the rest of the demo like this. There we go. I think I counted about 17 of these that I had to fill in. I just ended up, oh, man. So you can imagine the joy of that. Excel, maybe a little bit better in some ways. We can pass nulls rather than ref missings. But look at this piece of nastiness. This worksheets.add, I don't know if you can see that tooltip, but that's returning an object rather than a worksheet. Now, I know it's a worksheet because I'm going to cast it to a worksheet on the very next line. But I'm now having to use this mucky cast. And also, look at this. I've got to use this get underscore. That doesn't look like C#. Doesn't look like C# at all. That should be a range property. Set value. What's all that about? That's all horrible. It's all wrong. So how does that look when we actually look at it in a more up-to-date version of C#? Well, it looks an awful lot cleaner. So here we go. I've got my copy of Word. I do an add. I'm not having to pass any arguments there. All of those ref missings have been filled in for me. I'm able to use, again, range doesn't need any ref missings. And look here, I'm able to use a name parameter to get a file name. I'm able to pass a literal string in there because C# will figure out, I know com says it's a ref, but it can't really be. I mean, that'd be crazy talk. So it will allow me to ignore the ref and just pass a little string in there. And look at all those ref missings that aren't there. Isn't that beautiful? Isn't that beautiful? Come on, it's beautiful. You're hard to please. Okay, so if we run that up, get pretty much what you'd expect. We've managed to run Word up, and if I go and look at my documents folder, then yep, we can see that save as did actually work. It managed to get the right file name. Everybody's happy. Similarly, if we have a look at the Excel world, this wasn't quite so bad before. We had to pass nulls in, but now we're not having to do anything at all. This var worksheet, that's come up as dynamic rather than object when I do that add. So that means that I can now do this range. I'm not going to get any IntelliSense on that, but that range property will now be resolved at runtime against the Excel object model. Essentially, Excel will be sent the string range. And look, I'm able to use an indexer rather than a get underscore range. I'm also able to just set the dot value property rather than having to call a set underscore value method. So again, if I run that, we'll see Excel come up. And again, you can see that value has been inserted in there, so everything is indeed working the way that we'd like it to. So we're actually running a little bit early here. So if people have got features that they want to know a little bit more about, dive into any more detail on any of these things, then we've got a good few minutes. So sing out. Let me know. What do you want to see? Tuples? We've got to vote for tuples. Okay. So I got into trouble for telling a colleague that tuples weren't a language feature, but I stand by it. They're not a language feature. They are a handy thing to have, but what they really need is language support, which we don't have at the moment. So what is a tuple? A tuple is kind of like it's like an anonymous type, only it's even more anonymous. Anonymous type doesn't have a name. A tuple is just essentially an ordered set. So if I can't be bothered to create a type, then what I'll do, I might go, so I need something that will just hold an integer and actually let's have a boolean and a string. So maybe if you think about, say, the dictionary try get value method, that has two return values. It returns a boolean to say, did I find the key in the dictionary, and an out parameter to say, what did I actually find if I found anything. And out parameters are pretty ugly. They're pretty messy. So what we'd really like to do is be able to return two values from try get value. We'd like to be able to return the boolean and the string, but we're too lazy to create a whole new type for them. So tuples are a solution to that. So if I go tuple.create true Bob, then if we hover over that, we can see it's created something called a tuple of T1 and T2, particularly a tuple of bool and string. So this allows us to have, essentially, if we need a cheap way of packaging up several bits of data into one object, and we're too lazy to create a struct or a class with a meaningful name and meaningful properties for them, then we can use a tuple. And tuples have got very little in the way of properties. They're immutable. You can only access them once they're created. So you can see this has got tuple.item1, tuple.item2. Tuples go up to about 8, because if you're putting more than 8 things into a tuple, you probably should be giving it a meaningful name, because item 45 is just not going to help you maintenance programmers. Though I've seen code that looks like that, so who knows. Button 67, anybody? The reason I didn't talk about tuples before is because tuples have no language support. So I talked about dictionary.tryGetValue. If you use the dictionary.tryGetValue method in the F# language, that F# adapts that so it does return a tuple, and in F# you can return the elements of a tuple and crack it apart as part of that assignment. So you can effectively write the equivalent of, and this is not valid C#, which is why it keeps complaining at me. So in some languages, you can write something equivalent to that, and that will basically crack apart that tuple. It will put the first element into found, and the second element into value. However, C# and Visual Basic do not have language level support for tuples like this. You can deal with tuples, you can treat them as generic types, these simple anonymous kind of types, but you can't actually, there's no extra language level support the way there is in certain languages. Does that answer the question about tuples? Does that help with that? Excellent. We've got another 5 minutes or so. Sorry, over there. Thank you. Does Visual Basic support the dynamic keyword? Visual Basic has always supported the dynamic keyword. It's just that in version 1, everyone told us to turn it off. So Visual Basic supports, or has always supported, late binding. But the default, or the encouraged behavior back in the good old days was we told people to always put options strict on. So let's have a quick look at that. So I may have to just pull some code across here. Just bear with me while I try to get C# to compile in Visual Basic. I could obviously add an assembly reference, but that would just make life too easy. So there we go. So function, make something, mystery parameter, hoop, as Boolean, as object. If mystery parameter, then no, we don't want any of this stuff. We don't want this. We certainly don't want any squirrely brackets. And if end function. Oh no, okay, there's too many things to complain about. Okay, let's not worry about that too much. Let's just return Bob, because that's easier. You're going to compile now? Fantastic. Okay, so that's returning an object. So let's have dim o equals make something true, console.writeLine o dot length. So let's just build that, and look what's happened there. Even though this is, even though O is of type object, so we'll actually persuade it as object, that's still compiled. So even though object has not got a length property, that has compiled, and if we run it, then you can see it has actually managed to call the length method of the string correctly. So that is doing dynamic dispatch. It effectively, as object, is the dynamic keyword. But people have always been discouraged from using it because the recommendation has been to use, and I'm not a VB expert, so I may put this in the wrong place, option strict on. An option strict on says, compiler, I want you to check that I'm doing things right. I want you to prove to yourself that all these methods and properties that I'm calling actually exist. Check my work for me. The default is option strict off, and that gives you the dynamic behavior. That means the object will behave the same way as dynamic does. It will allow you to call things that may or may not exist. Option strict on forces that check. As far as I know, there is not a way, like there is in C#, of saying I want this variable, I want to bypass checking on this variable. There's only that kind of global setting of either Wild West, let me on my own, or check everything. So I don't think there's a way of doing per variable dynamic. Does that answer your question? Fantastic. Got a couple more minutes. Any more questions? Any more topics people want to flag up? Okay. So, just can't go that final PowerPoint. So, basic summary. Visual Basic, we're getting up some C# feature parity, things like the array literals and collection initializers, and we've got those convenience features like not having to type those line continuation characters. C# also, again, moving towards Visual Basic parity via COM interop improvements and language interop improvements. And common, again, that COM helper of the no-peer embedded interop types, and the idea of type-safe generic variants so that you no longer have to worry about those little fiddly generic type mismatches. Just makes life a little bit easier, makes life work a little bit more the way you expect it to. Okay, that's all I've got to say. Thank you very much for your time. Thanks for coming along. I hope it was useful to you.